Okay, here are the solutions to lessons 12 and 13 practice problems. Number 1 here, 1 through 4, I believe, 5 are from 12, and then 6 through 9 are from 13. So number 1, the polynomial function p of x has a known factor of x minus 4, and so we want to write it as linear, a product of linear factors. And we know the 1, and so we can start with that and use our diagram method for dividing. That's what lesson 12 is about. So we're going to put x and negative 4 over here, and then start filling in these little squares here. So here we need to get an x cubed. So we're always trying to get the next term in this polynomial function as we go through this. So this term and this term will be the first and the last terms. And then each middle term will be the sum of these diagonal boxes here. So that's kind of the plan. So in order to get x cubed in this first box, we need an x squared up here. And then when we multiply that by negative 4, we get negative 4x squared down here. So that paired with what we put here has to give us that negative 3x squared. So we need a positive x squared here in order to get this. And so that means we have an x up here, and that gives us a negative 4x down here. Then in the next box up here, we need to pair that with the negative 4x and end up with that negative 10x. So that means this has to be a negative 6x, which makes this a negative 6, and then this becomes a positive 24 down here, which is that last term. So far we've got a linear and a quadratic now. We've factored down to this term here, that polynomial. So far we have p of x is equal to x minus 4. Getting ahead of myself there. Times x squared plus x minus 6. And then we need to factor that quadratic, and you can do that using your guess and check. So I'm going to make 2 factors here, linear factors, and these terms both have to be x, and I'm going to have to multiply to get negative 6, but add to get a positive 1 here. So that would mean I'd probably want to use positive 3 and a negative 1. So just double checking, this times this does give me the x squared. X times 3 gives me 3x over here on scratch paper. Negative 1 times x gives me a negative 1x, and when I combine those I get, this should have been a 2. Thanks. Let's see. So this is a 2. So yeah, when I combine those, I get the 1x, and then the last times the last gives me a negative 6. So I have x minus 2 times x plus 3, and I can add that to the linear factor that I already knew, and my function p of x becomes those 3 factors. They're all linear, and so I'm done. Oh, and then a rough sketch. If we draw a rough sketch, we know that it goes through then at, if x minus 4 is a factor, it's going to go through at positive 4, and it's going to be a straight line through because that has multiplicity 1. It's also going to go straight through at 2 and straight through at negative 3. The y-intercept is 24, so if we go up by 6's here on the y, we know that it goes through up there, so it's going to come down. Since this is positive x cubed, it's going to have this shape, and behavior will be down, then up, then it's going to go through here, and then back up, and then end behavior as x gets very large will be positive. Letter number 2, Tyler thinks he knows one of the linear functions or factors of this function p of x, and he, after finding that p of 1 is equal to 0, he suspects x minus 1 is a factor, and that would be true. Here's the diagram he made to check, see if he's right, but he set it up incorrectly. So what he's done here, it looks pretty good, but he needed to use a negative 1 here. If x minus 1 is a factor, then that's where you would put the x and the minus 1 there. So that's his mistake on that one. Number 3, we're given polynomial q, and we're given that we know 2 factors, x minus 2 and x plus 1, and so we want to find the other 2. There's up to 4 factors since it's a quartic or fourth degree polynomial. So let's just start dividing, and we'll use the diagram method here. And first I'm going to divide by x minus 2, so I'm going to put an x there and a minus 2 there. And let's see, set this up so I can fit them all in here. So here I want to get 2x to the 4th, and in order to get that, I'm going to multiply this by 2x to the 3rd. Multiply that x, and so now I do the same thing with the 2, so I have negative 4x to the 3rd down here. Then paired with this, whatever I put here, I need to get a negative 9x cubed, so I'm going to make this a negative 5x cubed, which up here then, I'm going to have to multiply this x by a negative 5x squared in order to get the negative 5x cubed, which gives me a positive 10x squared down here. But I need a negative 12x squared, so in here I'm going to put a negative 22x squared, because then when I add those two I get a negative 12. So that means up here I'm going to have a negative 22x, and down here I'm going to have a positive 44x. But I need a positive 29, so I'm going to add a negative 15x into this box, which would make this a negative 15, which makes this 30, and that's good because that's what I get for my constant term. So now I've got it down to this factor, which is a cubic, so I'll use my other factor that I know about, x plus 1, and find and I'll factor this cubic function, or factor down a little bit so I can get it down to a quadratic, and then I can factor that out. So I'm going to use the method again, the diagram method, and I'm going to start with that cubic that I just found, that cubic factor, and divide it by this x plus 1 here. So now instead of going back to the original polynomial, I'm going to use this cubic factor that I have highlighted in yellow here. So I want a 2x cubed here, and so that means I'm going to have a 2x squared here, which makes this a 2x squared. Now paired with this, whatever I put in there, I want to get a negative 5x squared, so I'm going to go with a negative 7x squared there, so that these two, when I add them together, will give me that negative 5x squared. So that makes this a negative 7x up here, and that times 1 will give me a negative 7x down there. Again, pairing with whatever I put there, I need to get a negative 22x, and so I'm going to add in a negative 15x, which makes this a negative 15, which makes this times negative 15 times 1 a negative 15, which is good because that's what I've got for my constant term up there in this factor here. So now, so far, I have x plus 1 and x minus 2. Those two factors were given to me. And my third factor is 2x squared minus 7x minus 15. and now I can factor that. That quadratic. This was originally q of x. So I'm going to guess and check on that quadratic. And let's see, I need two numbers. I'll do my scratch work down here. Then when I multiply, I get negative 15. So, and this is going to have to give me a 2x squared. This times this. So, but when I add the outside terms and the inside terms, I'm going to have to get that negative 7. So I'm going to go with a negative 5 here and a positive 3, so that I have negative 10x and positive 3x, which would give me that negative 7x. So there are my other two linear functions, or factors then. And there I'm done. 4 factors, and they're all linear. And if you would multiply them all out again, you would get the original q of x function. On the next problem, we want to state the degree and end behavior. So the degree here is 3. And the end behavior, since that's our leading term there and it's positive, it's going to behave like the regular third degree functions. As x gets very large in the negative direction, f of x gets more negative, and as x gets very large in the positive direction, f of x gets more positive. So you can write that out however you'd like. Number 5, what are the points of intersections? Okay, so this one is kind of interesting. F and G look almost the same. We have x plus 3 and then x minus 1. And then over here we have x plus 1 and then x minus 3. So they're almost identical. The signs are different, though. So there's a couple of things we could do here, but I'm just going to multiply them out. So I'd have x squared. X times negative 1 is negative 1x, and 3 times x is positive 3x. So I'm going to get a positive 2x for my middle term, and then a negative 3. And then over here I have x squared, and then x times negative 3 gives me a negative 3x, and 1 times x gives me a positive 1x, so I'm going to get a negative 2x here, and then a minus 3. So again, almost identical. So when I start setting this equal to 0, I'm going to move all of these terms over to the left side, and when I do that, these terms cancel, these terms cancel, these all went to 0 like I wanted them to, and I get 4x is equal to 0. So dividing both sides by 4, my solution here is x is equal to 0. That's a point of intersection, so I need the other coordinate. So if I put if I put 0 into the function f, say f of 0, I'll get 0 plus 3 times 0 minus 1, which would be 3 times a negative 1, or negative 3. And similarly, if you would put that in for x and g of x, you would get a negative 3 as well. So just one intersecting point there. And now we're on to lesson 13, problems and long division. So for the first one, number 6, I'm going to write this out for you, x minus 4. That's our divisor, and our dividend is x cubed. There is no x squared term, so I'm going to put one in just to hold a place there so I don't get too confused by this. So I'm just going to add a 0x squared, and then minus 21x, and then plus 20. Now I can start multiplying. X times x squared would give me that x cubed that I need, and then x times x squared times negative 4 gives you minus 4x squared. And then we're going to subtract those just like you do when you do long division with whole numbers. So Subtracting is like adding a negative, so we can think of this as adding a negative 3 and a positive 4x squared. So I have 4x squared there. My x cubed terms drop out, which is what we planned. Bring down the negative 21x. So I need now a 4x, just a 4x, right? So that would give me a 4x squared. And then 4x times negative 4 is negative 16x. And when I do the subtraction here, or adding a negative, I'm going to add 16x to that positive 21x, which would give me a negative 5x. Then I'm going to bring down the 20. And now I need a negative 5 here. And when I multiply, then I get a negative 5x, which is what we wanted, and then plus 20. But I'm going to subtract that or add the opposite. So I can change this to a plus and that to a plus and that to a negative, and I get the 0 remainder, which I expected because we know that x minus 4 is a factor. But what this did for us now is it got it down to x minus 4 times the quadratic x squared plus 4x minus 5. And once it's down to that, then we can factor that quadratic and have our other two linear factors. So, so let's do that. We have b of x then is equal to x minus 4 times, we got x squared plus 4x minus 5. And now we just need to factor that quadratic there. So this will be an easy one to factor. We need two numbers that when we multiply we get negative 5, but when we add we get positive 4. So it has to be a positive 5 and a negative 1. That's the only possibility there. So because when I multiply I'll get negative 5, but when I add I get positive 4. Number 7, it tells us that p of x, x plus 9 is a factor. And to rewrite that function as the product of two factors, long division was used, but an error was made. And so now the question is, how can we tell by looking at the remainder, 990, that an error was made somewhere? Well, if they want to write this as a product of two factors, and we know that x plus 9 is a factor, this should be zero. I'll write it out. If we know that x plus 9 is a factor, then when we get done, we should get a remainder of 0 there. So looking at the factor gives us a hint that there was an error made there. Number 8, we start with a quartic or a fourth degree polynomial, and we want to divide by x minus 5 to find all the other linear factors. So this is going to take some guess and check, but let's start with x minus 5. We'll factor that out, or divide that. So we have x to the fourth minus 2x cubed minus 21x squared plus 22x plus 40. And let's see, in here we need an x cubed, so that when we multiply we get this x to the fourth. So that gives us minus 5x cubed here. Subtracting or adding a negative, however you want to think of that, would give us a positive 3x cubed. So up here we need a plus 3x squared. And then we'll bring down minus 21x squared. So in order to get the 3x cubed, we need a 3x squared. Let's see. Oh, I've already put that up there. So let's do the multiplying then. So we have 3x cubed minus 15x squared then, and subtract. or add the negative. Change that to a positive then. So this becomes negative 6x squared. So up here we need a negative 6x. And we need to bring down that positive 22x. And then do the multiplication. So we get negative 6x squared plus 30x. Because it's negative 5 and negative 6. So then we do the subtraction or adding the opposite. So this becomes positive 6 and negative 30, which gives us a negative 8x, which means that I need a negative 8 up here, and I'm going to bring down that plus 40, and then multiplying. Negative 8 times x is the negative 8x we wanted, and then we get a positive 40, and when we add the opposite here, we get the 0 we thought we would. So now we're down to the linear x minus 5 and the third degree polynomial x cubed plus 3x squared minus 6x minus 8. And so we want to select all the other linear functions. We don't have another factor to divide this third degree polynomial with, but we can just go through and kind of guess and check. If this is a factor, if it is a factor, then we should be able to get 0 here. So let's look at what makes x cubed plus 3x squared minus 6x minus 8. Let's look at what makes that 0. So if x plus 1 is a factor, then negative 1 should give us 0 in here. And so does that equal 0 is the question. So we have negative 1 cubed is negative 1. Times 3 times negative 1 squared would just be plus 3. Minus 6 times negative 1 would be plus 6, and then minus 8. So yes, we do. We have negative 8 and negative 1 gives you a negative 9, and then a positive 9. So this does equal 0. So letter A is a factor. So now we have another factor right away. So what we could do with this then, let's save this off over here. We could divide that out again. Let's see. I don't think I need this actually, so let's just cut it. So let's divide the x cubed plus 3x squared minus 6x minus 8 by x plus 1. And we'll use our long division again. And then we should be able to get it down to a quadratic, which we can factor hopefully easily enough. So now we need an x cubed there, so I'm going to put an x squared there. That gives me an x cubed plus x squared when I multiply it. Subtract or add the opposite would give you 2x squared down here, 3x squared minus x squared. Bring down the negative 6x. Then I would need a plus 2x here, so that when I multiply I get a plus 2x squared, and then that would give me a plus 2x. Subtract or add the opposite would give me a negative 8x here, and bring down the negative 8. That means I'd have negative 8 there, and I do get a 0 for my remainder, which is what I thought I would. So now I've got the quadratic I needed that I can factor easily enough. So let's see, let's get rid of this or move it off to the side. So my quadratic here is x squared plus 2x minus 8. So I'm going to factor that to two linear factors. One is, they both start with x because I need to get x squared, and then I need to get a negative 8 when I multiply but add to get a positive 2. So I'm going to use negative 4 and plus 2 because that would give me x squared, positive 2x, negative 4x would give me, oops, I'm going to change this to negative and make this one, I'm sorry, change the 4 to positive and make the 2 negative. That way when I do x times negative 2, I get negative 2x, and 4 times x is a positive 4x, which give me the positive 2x that I need, and then 4 times negative 2 is negative 8. So those are my other two linear factors. So I have this x minus 5, I have the x plus 1, and now I have x minus 2 and x plus 4. So there they are, D and E choices. Number 9, our last one here. Let's take a look at that quickly. Match the polynomial with its constant term. So the constant term is always the product of these last terms in the binomial factors. So if we take negative 2 times negative 3 times positive 7, we'll get 6 times 7 or 42. So A is 4. B, we have 2 times negative 3 is negative 6 times 7 is negative 42, so that one is 2. C, 1/2, we have to include that 1/2 now, times negative 2 times negative 3 times 7 would be 1/2 times positive 6, which is positive 3 times 7, which is 21, so that's choice number 3. Letter D, we have 5 out here in front, so now I have to include that times the negative 2 times the negative 3 times the positive 7. And so that's going to be 5 times 42, which is 210. So D is 5. And E is going to be negative 210, so that's going to be 1. All right, I hope this helped, and thank you.